Yeah, this one that is this one here was not showing up, and I don't think this one was showing up either. Actually, I should have 1, 2, 3, 4, 5, 6, 7, 8, 9. I think altogether, and I'm showing up with 1, 2, 3, 4, 5, 6. Oh wait, okay, so that's there now.
Yeah, exactly.
Okay, and should be one more.
They should be all there now.
Okay, and let's see. Yes, okay, perfect.
Okay, you can start sharing them.
Okay, excellent.
Not just because they see a new deck is being shared.
Yeah. Excellent. So, my name is Spencer Dawkins. I am not Aaron Falk, who did all the work, but he is moving this weekend and does not even have internet access, the last I heard. So you got me, and we're starting maybe 1 or 2 minutes late, which is not bad for the first session of an IETF. I should also mention that the entire Meet Echo team is in the NOC watching me, so it's like they know who needs to be watched. This will surprise no one, right? And so just to get us started here, I have a few ground rules that will be very short and I hope helpful for people. The HOTRFC is a request for conversation, and it's a good way to find people to talk to for various reasons. Barry, are you in the queue? Oh, okay. Thank you.
It works.
Yes, the queue is testing is working also. I'm serious. It takes a lot of people to keep an eye on me. But HOTRFC is a thing we started probably about 4 or 5 years ago that is a good way to find people at the IETF to talk to for various reasons. And we don't ever really ask what reasons people have for wanting to talk for 4 minutes, because that's how long people talk, is for 4 minutes. I have not, I'm a working group chair and we use Meet Echo, but we never meet in person. So I'm going to be learning a couple of things as we go, as I'm bringing people in and out of the queue. So each speaker gets 4 minutes, and your time does not start until I say go, so that you don't have to, be fumbling is, my time, not out of yours. And then at the end of 4 minutes, or at the end of your talk, we will all applaud. And when that happens, please hand the microphone over. We don't do questions here. So each person who's speaking is providing follow-up information, and the conversations can begin at any point. I notice now that we are meeting earlier on Sunday nights. You can grab somebody in the hallway and go to dinner, maybe. But do the right thing. So this is our agenda for tonight. If I'm remembering right, we have 8 speakers, yeah, and a variety of topics, which is always true for HOTRFC. And so I should also mention that about half of our presenters, I think, are remote. So we will make sure that they are online before their time starts. Donald, do I have you? Yes. Excellent.
You can hear me, I assume? Yeah.
Yes, excellent. And they were suggesting that I might do you want me to do your slides, or do you want me do you want to do your slides?
I'm not sure what's the best. If I ask to share slides, can I drive from the slides you have or uploaded, or?
Yes, you can now. I am told by a smart person in the back of the room.
Okay, well, let's give that a try.
Okay.
Let's see. How do I?
I just clicked a button that said grant pre-shared slides.
Okay. Well, actually, but you seem to have shared your own slides rather than mine. So I can now drive your slides, but not my slides.
Let me
Let
me stop doing that. How on earth do I do that?
I think you somehow have to select my presentation or something.
Select his presentation, and then you hold the floor and you keep the floor to him.
Okay. So I had my slides up, and so
You stop sharing the ones that you were sharing, you share again, and you select slides that he has to present.
okay. So I am sharing
This one,
preloaded slides,
and you select his deck,
and I am
his slate.
yes.
And
Okay.
then that's it. You make share, and you ask him to take the floor as you did.
Okay, Donald, you should be able to take the floor now.
Okay, but I don't see the thing for changing slides.
It's actually down at the bottom on my screen.
Right, but
Hand control over to him. No, here.
Here, okay. Okay.
okay. So launching right into this. This
Excellent. And
yeah.
I will say go when I start a timer, and I'm starting a timer now, so go.
Okay, this is Donald Eastlake with FutureWay, and I'm going to present an idea for an easy method for applications to get various quality of communication services. And the idea is this could benefit even a completely QoS ignorant application using ordinary unmodified APIs. And what sort of things are we talking about? Possibly ways to get improved bandwidth or latency or whatever by tweaking header fields, or maybe using a slice if you have network slicing and things like that. And this would mostly be useful in a localized domain. No on-the-wire protocol changes. And of course, if the application is aware of QoS and things like that, it can perhaps have better control and be able to do more detailed and complicated things. So what happens when you make a network connection these days? It's pretty easy. Your application typically goes to the DNS, the name, gets back an address, makes a connection. You talk to this remote network interface. So what would be different with this idea? Well, the idea is that you somehow encode the QoS desired in the request to the DNS. And in the DNS response, there's information about the method for obtaining that QoS. And possibly the application that's using its ordinary APIs, doesn't really understand that, but maybe your first hop router or some early hop router understands that and can tweak your packets to get the desired effect. So how are you going to do that? Well, the DNS request, the best flexible part is the name you're querying. And there's a separate draft which talks about how to express QoS requirements in DNS requests. And for responses, the idea is to use semantic addressing. And that means that the address does more than just identify a network interface, but also has additional information about how to connect to that address, for example, in the low order bits. So maybe just get a quad A record back and the low order bits tell you how to actually do it. And as I mentioned, the first or an early hop router can make selected modifications perhaps to the packets on the fly or make the right routing there. So in the case of an application which has no changes at all, then you have to have it be configured with, or somehow give it this DNS name which has this QoS in it. If it's DNS name knowledgeable, then it can construct such names perhaps to request various qualities of service. Maybe the extension of all this, there'd be new RR types, not just semantic addressing where you just get an address. And of course, you can combine 2 and 3 together. So what kind of quality of service are we talking about? In a course level, you might want to just say, I'd like a minimum latency because I'm a gaming application, or I want maximum bandwidth or the like. You'd also like to be able to specify more precise metrics, perhaps some maximum jitter in microseconds or minimum bandwidth in megabits or whatever. So for more information, there's this draft on how to express these requirements for QoS, and there's a draft on semantic routing, and Hayu Song and I are the authors of this, and hopefully people will get more information. I am, by the way, presenting on the expressing QoS requirements draft during the DNSOP working group meeting this week. So that's it.
Thank you, Donald. Our next person who will be speaking is Mark. Mark, you are in Meet OIC. Can you put yourself in queue? Yeah, okay. Here, you're popping up. Excellent. Okay.
Hello.
Hello. And I am sharing preloaded slides for you, and it looks like this one. Is that working for you?
Yes.
And trying to remember, do you? How do I put you in charge of this? Oh, I need to hover over Mark's name. Cool, there. And this one. Press slide control.
Yeah.
Okay, yeah, perfect. Sure. Thank you, Lorenzo, also from the back room. Cool. So Mark, can you control your slides now?
I do not see how. Oh, yeah, okay. I see. All right, yes, I can.
Okay, excellent. So I am telling you when to start, and you can start now. Go.
Hi, so my name is Marc Petitgonin, and I'm going to talk about verified internal draft using computer-aided specifications. So the idea of a computer-aided specification is to combine 3 things. Is to combine document format. In this case, I chose ASCII-doc. So-called dependently typed programming language. I chose IDRIS2, which is one that was fitting my need. And this is augmented with the ability to take the result of a computation done in IDRIS2 and to inject the result of this inside the document that is processed. So I developed a tooling which permits to take a document in this format and to generate an XML to RFC v3 file from this specification, ready to be submitted as an internet draft. So here's a little bit how it looks. So this is in 3 parts. On the top, you have an extract of an existing computer-aided specification, which was RFC 89, sorry. And you can see that you have on top, you have on the left, you have this symbol, which is called bird mark, which signal where the code is. So this is some IDRIS code. And then you have the text, which has the insertion of some result, which start with code and are between brackets, right? So the text here will be converted into readable text. So the second box is the command which is executed to generate. So you can see here, from this text, we simultaneously generate the XML to RFC, the text, the HTML, and the PDF file from that. And on the bottom, you see the result of this, which is a various retransmission. So the idea is that you can simply change one of these parameters, number of retransmission or delay, and the system will automatically generate the correct thing, which is on the bottom. So the problem is that using IDRIS and computer-aided specifications that way is quite difficult. It takes some time to write this code. So what I have been doing for the last few months is to write standard libraries that contain predefined libraries for various things that are useful for people that are writing IETF internet draft, right? So this is done by using what's so-called embedded DSL. DSL is a domain-specific language, and which permit to construct some interesting things and to do that right? So I have a library for denominate numbers, ABNF, and Petrinet, which is still under development. There is other in development too. So just to show you how it works with an ABNF DSL, you can see on the top, you have, again, the code and the text. So the code is a simple usage of this ADSL to define here an ABNF rule. And then the code text, which is just underneath, will generate the thing. So it does 2 things. It verifies that your ABNF is correct. And by correct, I mean that all the rules have a different names, that all the names are used, at least one. It verifies also that your IBNF doesn't loop, right? Which is something which is not verified very often. But in addition, what it does is that it generates the alpha underneath, the text underneath. So that's all. If you want to know more, there is a document that contains everything, including how to download and install the tool.
Thank you, Mark. And so we would have Paul Congan talking next, I believe. And I think so.
I think I have to turn. Oh, there we go. Okay.
Yeah. I'm getting better at this, I swear.
Okay.
But haven't said go yet, so let me. Yeah. You're on.
Okay. My name is Paul Congdon, and I want to discuss with you a couple initiatives that are taking place in the IEEE that I think are of interest to the IETF, and particularly the IEEE 802.1. Next slide, please. So first of all, I'm going to be talking about standards going on in the IEEE. It's just my personal view. I have to show that disclaimer slide. Next one, please. So there's 3 initiatives that I think are most interest, and it's motivated by low latency, low loss, high reliability, Ethernet-based data center networks that support RDMA and AI and HPC workloads. The three initiatives are congestion isolation. I've talked about this before in other hot RFCs as well as ICCRG and other places. PFC enhancements and source flow control. All of these are amendments to the big standard 802.1q. And you can find a lot more background information on this paper we published recently about lossless data centers. Next slide, please. So real quick, congestion isolation. If you're familiar with the way data center networking works today, we're using ECN marking to indicate congestion that gets fed back to the source. And hopefully the source slows down quickly enough. If it doesn't happen quick enough, we may invoke priority-based flow control, PFC, in order to not drop any packets, because loss is a problem with some of these protocols. So there's some problems with priority-based flow control. In particular, it creates head-of-line blocking, congestion spreading. It's difficult to use. So congestion isolation, what it does is it identifies the flows that are causing that congestion, and it uses a separate queue or a separate traffic class. And so it moves them out of the way in an attempt to avoid using PFC. It has a signaling message that goes one hop up, and it can be a layer 2 or a layer 3 message. Again, I've told you a lot about the standard in the past. It's pretty much done. It's in its final stage, the equivalent of last call. Next slide. So PFC, as I mentioned, is still used today. However, it's very difficult for many people to use. It requires that you calculate what's called headroom, which is the amount of buffer you need in order to absorb packets in flight. And that's dependent on cable length, but also internal delays and implementation details. So it's complicated to figure out what PFC headroom should be. So this enhancement uses the persistent time protocol to automatically measure the delays between the instations and automatically calculate that PFC. So there's no requirement for user configuration. We also found a problem with PFC being encrypted over MACsec protocol. And so we're going to fix that as well in this enhancement. Next slide, please. I think the one that you're going to be interested in is source flow control. Now, source flow control uses some of the ideas of congestion isolation, but it doesn't move any traffic to a different queue. What it does is it signals across the network and remotely invokes priority-based flow control. So it avoids some of the problems of priority-based flow control in doing that. Again, this is a brand new project, just getting started, so it's an opportunity for people to get involved. So next slide. So I have scheduled a side meeting for this week to go into the details of all of these protocols in much more depth. We do have a non-IETF working group mailing list that's been around for a while as well. That's for people interested in congestion control for RDMA. And I'm going to use a Microsoft Teams as well during that side meeting, so try to bring other people in. So I made it.
It was perfect. Thank you. And close that deck. And yeah, next one is Ulrich. And let me bring your slides up.
That would be too lovely.
You are the trustworthy digital supply guy?
Sorry?
Was your... no, that's that one.
Something with multi-signer somewhere.
Yeah. Or
Yes.
Yeah, that one. Okay. And I am doing that one. And
There we go.
okay, and we are go.
Okay, hello, my name is Ulrich Wisser. I work for the Swedish Internet Foundation, and this work combined with Schumann Hook, and we are working with a whole group in the multi-signer project. Next slide, please. And our goal is to fix some inconsistencies in the DNSSEC RFCs. And the next slide, please. And so short recap what multi-signer is. It basically is the idea that you have a DNS zone and you have two independent signers of the zone that sign the zone and dispute it on the internet. And for this to work, you have to exchange ZSKs. And next slide, please. And we hop over that one. Next slide, please. This is just for reference if you want to look at this later. So there's a challenge in this that the providers have to use the same algorithm. And if they use different algorithms, then you got problems. You can't do this basically with today's RFCs. And we think that is a problem that should be closed, because one of the, let's say, special applications of multi-signer is that you can have a signer currently and you would like to move your domain to a different signer, and you don't want to go insecure, then you need to do multi-signer in the middle. And well, if you're big enough, maybe they would, the service providers would humor you and use support the algorithm you want. But for most of us, this won't happen, and you just have to use what they give you. And if they give you different algorithms, you can do this. Okay, next slide, please. And so the problem is that in the DNSSEC RFC, it says that if there is an algorithm in your DNS key set, then you have to have signatures for it. And next slide, please. And of course, if you have a signer that doesn't support one of the algorithms, then you can't do that. And so then there's another RFC that says, well, if you are a resolver, you shouldn't look at this. You should only see if there is some valid signature, and then you should accept the whole thing. And obviously, these two RFCs are not totally in sync about what's the right way to go here. And so next slide, please. And we think one of the part of the fix could be this in RFC 6840. It says should not insist on this on all algorithms. And well, an obvious solution here would be a must not. That would make life very much easier for us. Next slide, please. So, and then there is validation requirements, obviously. So if a resolver gets an answer and it doesn't support the algorithm that just this name server instance gives back, then obviously there's a problem. And we would need to find a fix for that. And that is why we're here today, because there's some questions left with this, how we make this work. And we would very much like input from the community. And next slide, please. Because this is the next problem, it's downgrade protection. Because we heard a lot about this, having all algorithms in all signatures is a type of downgrade protection. And well, maybe it is, but I think we would need to talk about the security properties of the whole solution. And I think there's hopefully some people here in the room that are more qualified to discuss it than I am, and we would be really happy to talk to you. And with that, I have 1 second left. I'm done. The rest is just.
And so this is your last slide, right? Cool. Thank you.
Yes. Thank you.
And I believe that brings us to Kieran. And I think Kieran is remote. Let me find slides for that. And
can you hear me?
And so this visualization of PLC, right?
Yes.
Okay. And I'm sharing that. And let me figure out how to, oh, sorry. I think you should be able to control the slides now. And let me reset a timer.
Yeah.
So you can control the slides? Are you seeing the controls for
Yes,
that?
I can. Okay. Hi, everyone. My name is Kiran. And, I'm receiving a lot of feedback. Is it just me or is it coming from the room?
Yeah, if you're not,
Anyway,
if you're not presenting, please mute, definitely.
I'm trying to promote a topic on industry control networks. And as you know, automation in industry and factory floors is growing. There are a lot of sensors and devices that make automation happen and control processes on the factory floors. And behind all the sensors and devices, they are controlled by rugged computers called PLCs, and they are the basic building blocks of process control and automation. And they are helping robotics, motion control, smart manufacturing, smart factory type of use cases. And as the automation is improving, these PLCs need to perform a lot more complex tasks, which means they should have more processing power and more memory to run more number of scan cycles. And they come in different sizes, and it depends on what kind of process they are controlling. It could be something as simple as receiving the temperature information or exerting the pressure, changing the valve values, or it could be more complex processes where you're controlling multiple sensors and actuators together, or it could be one PLC controlling multiple other PLCs. So the general architecture for the PLC is on the left-hand side, that you have a control unit which comprises of CPU and memory, from where you do all the programmable aspect. And then there are IO modules that actually control the actuators or sensors on the factory floor. So my idea is actually this idea is pretty common, and it's picking up. The trend is, can we virtualize the control unit away from the IO modules? It has several benefits, that now you can control the size of control unit. You could customize memory and power, compute power based on your requirement. And you also don't need to build up rugged cages or something to maintain your PLCs on the factory floor, because many times they are in the harsh environments. So it's a great idea to work on virtualization, but the structure of how information flows on factory floors is pretty hierarchical. And one of the key requirement for supporting virtualized PLC is to disaggregate this thing, and how the network will change. This is what I'm working on. We will try to answer some of those questions, that how do you deploy virtualized PLCs, and what are the different properties of the PLCs in terms of addresses, verification, how you allocate compute resources to those devices, and some other questions listed here. I will talk about this thing in more detail during IoT Ops, and I've posted the time for the meeting as well as where we can have discussion. If you guys are interested in this work, please join me. Thank you.
And is Berta? Let me bring up your slides, and then we can get you going. And is the white area? Yep. Okay, so we have that up, and I'm restarting your timer. You're on.
So, hello, my name is Berta Serracanta, and I'm a PhD student from Universitat Politècnica de Catalunya. And today I'm going to talk about wide area network autoscaling for cloud applications. Next slide, please. So imagine we have this scenario where there are three main parts. The first one would be a company branch where there are all the users located. The second one would be the cloud side, where there are the applications that these users consume. And finally, the third one would be a software-defined network, which links both the users and the applications and provides them connectivity. And now imagine in this scenario, we have a growing number of users that require this application. So the load grows and the cloud decides to allocate more resources to that application so it can manage all the requests that they are getting. Next slide, please. So if we now look at this situation, we have seen that the cloud has done something which is great, but there's the danger that now the network becomes the bottleneck. So what we are proposing is a solution that tries to understand what's happening on the cloud so the network can do the similar things so we can avoid having this bottleneck. Next slide, please. So how can the network reroute to these cloud autoscaling events? In the cloud, there are two different things done. The first one being vertical autoscaling, which means adding more resources to replicas of the application that are already deployed. And the second one is horizontal autoscaling, which means deploying more replicas of the application to distribute the load more evenly. So by leveraging the software-defined networking's capabilities and its underlays, we have proposed a solution based on choosing the right path and allocating elastic bandwidth on tunnels to translate autoscaling to be also done in the network. And if you want to see more of actually how we have implemented this, you can come and see us at PanRG presentation that takes place on Thursday at 1 p.m. And also we have a paper, so if you want to scan the QR code, feel free to do so. Thank you.
Hank, are you here? Ah, okay, excellent. Walk slow and I'll get your slides up. No.
There's no box.
Is that a clock?
Let's see.
I guess that's a clock.
Yeah.
Hi, I'm Hank. And I'm going to talk about
No, so let me start reset our timer.
Sure.
And we are.
I don't want to be over time.
The presentations are getting shorter. No pressure.
No pressure at all.
Go.
So let me unpack the first slide slowly. So the title is Trustworthy Digital Supply Chain Transparency Services. And so I'm here on behalf of a lot of people talking about this. And so let me unpack the end of the parenthesis here. There's an email list on the slide. It's SCITT. And SCITT means supply chain integrity, transparency, and trust. So if you're interested in the topic, supply to that IETF email list. There are weekly meetings on Mondays. All this is not on the slide deck. But we have to present hot RFC stuff here. And there's two types of content. One of is about architecture, and one is about a specific cozy standard we want to promote here. So that's a hot RFC, and I already wasted a minute. So let's go with the next slide. I have 4 slides. So all of you know supply chains. This is a very specific one that's interesting to the IETF, I think, because this is about software. And I think there's a lot of hype about software right now because there's an executive order I heard about in the US, and it's somehow about securing cybersecurity, and I guess it's about software and also something called a software bill of material. But in the end, all this is going to solve a problem, and the problem is the auditability of all of that. And I think we as an IETF, we can help there because all of these red texts in this example that I just pulled from slides that we will present at SEC Dispatch, by the way, on Tuesday, shows a lot of problems that we can want more transparency about in supply chain. So next slide, please. So now I'm going to do a quick dive into the two things, which are the architecture and the receipts on here. So let's start with the right side first. Right. And when you have an artifact in your supply chain, it can be everything. It can be a fish. It can be a S-bomb, that's very en vogue. It can be a car. So anything, and there's an artifact that is produced and value-added in the supply chain that you can create statements about, and you issue them. And the issuing happens by signing them. And then you're an issuer. And this is again already cozy stuff. So on the left side, the receipt thing, you already see some CDL there. And then it reveals this is a countersigning thing. So when you have the issued signed claim, you can put a identity document thing, like I did this in there. And then this is a claim. Claim might be a bad term. Let's not talk about this right now. But then you put it to this transparency service. That's the ledger. You might heard a blockchain. That's not a blockchain. It's close to it. But it's an append-only ledger. And the important thing is you can trust this ledger. And then when you did the commit of this transparent claim to your supply chains, everybody wants to know about this, and come back, you get a receipt. And the receipt is a countersigning method about Merkle trees that we do. And then it's a transparent claim. So now we have this statement that is the statement about the artifact. You have the claim itself and the receipt, and now you can offline validate that. You can put trust in the ledger and the transparency service and just be offline. And that's an important feature, I think. But also you can go back to the ledger and do the service audit trail back to this, because at the bottom left, there's auditors. You want to make sure this all happened. Did it happen correctly? And so there are a lot of things in the drafts you can talk about. And we have a special receipt format that helps doing this. So the last slide, please. And I'm over, I'm so sorry.
No,
There's related work. There's COSI working group and there's the REDS working group. COSI is the receipt. REDS working group is helping the ledger to be actually authentic and do authentic things. And of course, this is somehow related to the certificate transparency work in RFC 6962. So all of this is interesting, I think. There's a conglomerate of people who really want to do this, and more about this at the SEC Dispatch. Sorry for being somehow over.
You and I were exchanging witty repartee for about 10 seconds at the beginning, so you were good. You were good. Have Daniel as the last speaker. Daniel, are you in MeetEcho? Okay, there you are. Excellent. I can. And I'm not going to share that anymore, and I'm going to share this instead. And
okay, so.
And you should be able to control these now, I think.
So I can see the first slide, but I'm not sure. Oh, yeah. Okay. It works. So.
Go.
Yeah, hi, everyone. So I'm going to talk about air-flight CO2 emissions associated to our IETF meetings. So the basic question is, can the IETF continue with business as usual? On the one hand, we have in-person IETF meetings, which involve around 1,000 international flights. And on the other hand, we have science that urge us to reduce our CO2 emissions. The IPCC 6 assessment report just partially being published, and already UN Secretary General called it a code red for humanity. The Guardian described it as the starkest warning yet of major inevitable and irreversible climate changes. So the basic question now we need to ask is what we should do and what can we do? So we started to ask ourselves a subset of questions, which are such as how, if we apply the IPCC recommendation, then what would be the impact on the IETF, if so? What is exactly the amount of CO2 emitted by an IETF for attending 1 to 3 meetings a year? And how following the trends of sustainable aviation would impact the IETF? And at last, should we consider sustainability in a broader sense than only the CO2 emissions? So this is a small study which we started. We have code, publications, and data all available on that website. We presented that to the IAB Ed workshops in November or December, I can't remember. And we will share that presentation again during the SHMU session this time during this IETF. So it's basically an invitation for you to come and to attend that presentation. So if we see how the report is being, the IAB report is currently reporting this situation is initial results suggests that the cost of holding multiple in-person IETF meetings per year are likely unsustainable, although the analysis is ongoing. So actually, we do have some results that are not that are a little bit more straighter than what the report is kind of suggesting. And what our conclusions are that holding 3 in-person meetings a year is unsustainable. And whatever path we take, it seems like limiting it to 1 per year is probably something we should aim at. And that sustainability goes beyond CO2 emissions, and that we would like maybe considering adhering to sustainability programs. So that's everything we're going to discuss in SHMU this week. Thank you.
Thank you, Daniel. So I wanted to thank all of the presenters who came tonight to give us 4 minutes of their best, and ask you all to make good choices, because that's always the right thing to do. Enjoy your IETF week, and we'll see you online or offline.
Bye.